video lesson on fractions, specifically adding and subtracting them. Adding and subtracting fractions is more challenging than multiplying and dividing them because we often have to take an extra step. You cannot add or subtract fractions that do not have the same denominator. And the denominator is the bottom number. For example, I could have the fraction 3/4 and want to add the fraction 1/3. These fractions do not have the same denominator. I have a denominator of 4 and a denominator of 3. I can't add them. To understand why, think of a visualization of which each fraction represents. If I make a circle that represents a whole, and I want to think of this circle as a certain amount of quarters, then I can divide my circle into 4 parts. Each part is a quarter. So the pieces of this circle that this fraction represents is the size of these slices or wedges. And if I wanted to represent 3 of these quarters, I could shade 3 of these slices or wedges to complete my visualization of 3/4. If I have another circle to represent a fraction in thirds, I want to make each slice a third of the circle. Quarters and thirds are different sizes. 1/3 I could shade to be one of the slices in this circle. Comparing quarters and thirds, I can visually see that they're different size pieces. So it doesn't make sense to add pieces that are different. Does that mean that I stop? I have to take an extra step to convert these fractions so that they have the same denominator before adding them. So if we cannot add fractions that have the same denominator, then I need to change them so that they do. And the way that we change them is to get equal denominators by or to get equal denominators, multiply each fraction by a version of 1 based on the other fraction's denominator. What do we mean by this? And most especially, what do we mean by version of 1? Let's continue our example. I have the fraction 3/4. I want to multiply this fraction by a version of 1 based on the other fraction's denominator. The other fraction's denominator is 3. So a version of 1 based on 3 is 3 divided by 3. 3 over 3 is 1. Something over itself is always 1. 3 divided by 3 is equal to 1. So I want to multiply the fraction 3 over 4 by this version of 1. Sometimes we can draw a large 1 over the fraction something over itself to remind us that we are multiplying by 1, and it's always okay to do so. It doesn't change the value of 3/4 to multiply by 1. But before we proceed, let's also do that to the fraction 1 over 3. I'm going to multiply by a version of 1 based on the other's denominator. The other denominator has a denominator of 4. The other fraction has a denominator of 4. So the version of 1 that I'm going to multiply over here is 4 over 4. Something over itself is always 1. Now with these choices, let's see what happens. Fraction multiplication, I multiply the numerators to get a new numerator. 3 times 3 is 9. I multiplied the denominators to get a new denominator. 3 times 4 is 12. In the other fraction, I have 1 times 4 for the new numerator 4, and 3 times 4 for the new denominator 12. And I'm adding these two. By multiplying each fraction by a version of 1, I made the problem into a fraction addition that had the same denominator. Now that we have the same denominators, we can add them. 9 and 4 is 13, and the denominator is 12. In our visual model, what we did by converting the 3/4 into 12s is the same thing as taking each of these quarters and splitting it up into 3 pieces each, converting the whole thing into 12ths, pieces that have a size that is 1/12 of the whole thing. And how many were shaded? If we started with 3/4 and turned them into 12ths, we have 9 of them shaded. In the fraction that was 1/3, converting it to 12ths was taking each third piece and separating it into 4 slices. And in doing so, we have now 12 slices in total, and now 4 of them are shaded to represent the new form of that fraction, 4/12. Let's have one more example. This time we'll subtract. Addition and subtraction are the same in that we can't do it unless they have the same denominator. These fractions are not ready to subtract because the denominators are not equal. But I'm going to multiply the 2/7 based on a version of 1, or times a version of 1 based on the other's denominator of 11. So I'm going to multiply the 2/7 by 11 over 11. I'm still subtracting. This fraction 6 over 11, I'm going to multiply by a version of 1 based on the other's denominator of 7, which is multiplying by 7 over 7. When we do, let's do the multiplication. 11 times 2 is 22. 11 times 7 is 77. We're still subtracting. The 7 times 6 is 42. The denominators, 11 times 7 is 77. And now that I have subtracting fractions that have the same denominator of 77, I can go ahead and subtract. 22 minus 42 is going to be a negative 20, and the denominator remains the same, 77. This takes some practice to get good at it and to get fast at it.